we're given the prevalence of chickenpox within the population. Okay, we're given the prevalence of smallpox in the population. We're given the likelihood that you'll generate spots, knowing that you have chickenpox. Okay, we're given the likelihood that you generate spots, knowing that you have smallpox. But what we haven't been given is, I mean, what's the likelihood that someone will have spots in the population? Okay, so that's a piece of information that's important for us. And actually, once again, based off knowledge, we typically have that probably about 8% of the population have spots. So the probability that you have spots, I'll just write that in here, maybe up here, the probability that you generate spots is usually 0.0008. Yeah, so 8% of the people in the population will generate spots. So now we can actually see what happens here. So the probability that you have chickenpox, knowing that you have spots, is equal to the probability that you have the disease, the prevalence of it in the population, which is about 10% of the population, 0.1, times the probability that you have spots knowing that you have the disease, which is 0.8, divided by the probability of spots in the population, which is 0.08. Okay, which when we look at this on the calculator, okay, this gives us 0.1 times 0.8 divided by 0.08 gives us a value of, well, actually, maybe what we'll do here is we'll just make this a little bit smaller here. Okay, we'll say that we have, did I put something in here wrong? 0.8 is good. So we have 0.08, 0. That's all good. Okay, so actually we're getting 1 here. Okay, it's very, very high. Okay, 0.8. Actually, maybe it's 0. Let's just make this a little bit smaller, 0.81. So actually we don't have a certainty happening here. So let's run this again. So the probability of having spots is about 8.1% of the population have spots. Okay, so now what we have is 0.1 times 0.8 divided by 0.81 gives us a value of, there you go, it's about 0.987. Okay, that's the probability. Okay. Over in this case here, the probability that you have the disease, knowing that you have spots, is the probability of having smallpox, the prevalence of it in the population is 0.001. The probability that you have spots, knowing you have smallpox, is 0.90, and that needs to be divided by the chances that you have spots, which is 0.081, which now gives us a value of the probability that you have the disease, smallpox, knowing that you have spots, is equal to, let's do this, 0.001 times 0.9 divided by 0.081 gives us a value of, oh, there you go, 0.011. Okay, so here's the real answer. Okay, so here was the dilemma. Let's walk through this again. So we have two answers now. Okay, we have this here and we have this here. Okay, so the dilemma that the doctor was faced with was that if somebody has smallpox, okay, they'll generate the spots 90% of the time. Okay? Whereas if someone has chickenpox, they'll generate the spots only 80% of the time. Now what we know is that the person has presented with spots to the doctor. Now what we'd like to figure out is what's the likelihood that they have a particular disease, knowing that they have the symptoms. Okay? Now when we work this down, okay, through using Bayes' theorem, we can actually see that something unusual is actually happening here. Okay? It's a nice example. It's actually the probability that you have the chickenpox, knowing that you have spots, is actually 98%. Yeah, 98.7, 99%. Okay, that's how likely it is that you have the disease, knowing that you have spots. Whereas the probability that you have smallpox, knowing that you have the spots, is actually only 1%. So you can actually see that it's a bit counterintuitive, yeah. Okay, but really, what we're trying to calculate when we're calculating these particular probabilities is these posterior probabilities, as they're called. Okay, it's the probability of a disease knowing that you have spots. Whereas a lot of the times, the information that doctors have is that they know from past evidence likelihoods of people with particular diseases after being diagnosed with a disease, and the certainty that they had the disease, yeah, and the symptoms that went along with that. Okay, they can actually generate these probabilities, and they also know the prevalence of these particular symptoms or of these particular diseases in the overall population. So what they really need to calculate is these particular probabilities, the probability that you have the disease knowing that you have the spots, rather than the probability that you'll have the spots knowing that you have the disease, which are two different things. Okay? So guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. This short video was dealing with Bayes' Theorem, an example, another video in our series of videos in probability theory. It can be quite complicated, this can, I do accept that, but you can actually see how interesting it really is. So once again, guys, I hope that this was intuitive, but more importantly, I actually hope that was helpful for you, and thank you for watching. Okay, bye bye.